Hi everyone, it's Miss Costa here, and in this video we're going to go through a predicted paper for what might come up tomorrow. Obviously none of these topics are guaranteed to come up, but it's just a best guess based on past papers. And I have made it a little bit harder than it probably will be tomorrow, but that's just so that you can practice all the hard questions and then tomorrow will be an absolute breeze. Okay, so for question 1, I've been told that A is made up of 2 squared times by 3 times by 5 cubed, and B is made up of 2 cubed times by 3 squared times 5. And they're asking me to find the highest common factor of A and B. Now, if I was being asked that normally, what I would do is list the factors of each number. I could do that by just listing the factor pairs, or I could have used a factor tree, and then I would have got their prime numbers. However, I can't use this method, but I do have another method that I could use when I don't know the numbers, and that's the Venn diagram method, where one of the circles represents all the numbers that multiply to make A, and the other one represents all the numbers that multiply to make B. And in here, we put any number that is common to both. So if we just write them out, 2 squared means 2 times 2 times by 3 times by 5 times 5 times 5. And B is made up of 2 times 2 times 2 times by 3 times 3 times 5. So I'm looking for any factors they have in common. So 2 is the first thing they have in common. I write that in the intersection. I only write it once because it's the number they both have in common. They have another 2 in common, so I'm going to write another 2 here. Then they've got a 3 in common, so I'm going to write that here. And then they have a 5 in common as well. So all of the factors they have in common are in this intersection. And to find the highest common factor, I just multiply all the numbers in the intersection. So I'm going to do 2 times by 2 times by 3 times by 5. 2 times 2 is 4, 4 times 3 is 12, and 12 times 5 is 60. So the highest common factor is 60. Now I can finish off my Venn diagram to find the lowest common multiple. So the numbers I haven't used are 5 and 5 for A, and then I haven't used 2 or 3 for B. So I now know that this intersection here, all of the numbers in here multiply to make 60, and to find the lowest common multiple, I multiply all of the common factors. So I'm going to do 5 times 5 times 60 times by 2 times 3. So let's just simplify that as much as we can. That would get me to 120, and then 120 times by 3 is 360, and 5 times 5 is 25. So I just need to work out what 25 times by 360 is. Now you can just do any multiplication method you like. I like the lattice method just because it means you only ever have to multiply 2 single digits by one another. So we just draw a 3 by 2 grid because it's a 3-digit by a 2-digit number, and then I multiply, and in the top part of the box I write my tens, in the bottom part I write my units. So 0 times 2 would be 0, 2. 0 times, oh no it wouldn't, 0 times by anything is 0. So 0 times 5 would be 0. 6 times 2 is 12, 6 times 5 is 30, 3 times 2 is 6, and 3 times 5 is 15. Now when I've done that, I just go along my diagonals and I add everything that is in each individual diagonal. So the first one is 0, the second one is 0, then I've got 5 plus 3, which is 8, plus 2, which is 10. So I carry the 1 into the next column. Then I've got 6 plus 1 plus 1 plus the 1, so that would be 9. So therefore, the lowest common multiple of A and B is 9,000. Okay, the next thing I have is multiplication and division with decimals. Now there's a really cool division fact that you should know, and that is, if I had a simple number like 6 divided by 2, that would give me 3. If I then multiplied both parts of the calculation by the same power of 10, so 60 divided by 20, the answer is also 3. If I did that for 100, 600 divided by 200 is also 3. So therefore it follows that 0.6 divided by 0.2 would also be 3. So I can use this division fact to help me with decimals. So what I want to do is I want to keep multiplying until I have a nice number to divide by. So if I times it by 10 first, that would give me 4.32 divided by 0.12. Not so nice. Let's times it by 10 again. That would give me 43.2 divided by 1.2. Still not an integer, still not 2 whole numbers. If I times it by 10 again, I'd be left with 432 divided by 12. Now I've got some integers, and if you're great at long division, you just do that. But if not, and this is a key division fact, especially for the non-calculator paper, if you don't know how to do the division, turn it into a fraction, because that's all division is. That line here, divide, is what this line here means, divide. So I can then simplify it until it's a number that I'm comfortable with. So 432 divided by 2 is going to be 216, and 12 divided by 2 is 6. And again, if you need to divide by 2 using the bus stop method, absolutely do that. Then I can divide by 2 again. So the first thing I did was divide the fraction top and bottom by 2 to keep it equivalent. Then I can divide by 2 again if I wanted to, so that would be 108 divided by 3. You could have, when you got to here, just use the bus stop method, but why not make life even simpler? So I'm going to do 108 divided by 3. 3's into 1 don't go, so 3's into 10 go 3 times, remainder 1, and 3's into 18 goes 6. So that must be 36, using this division law, that as long as I've multiplied both parts of the calculation by the same power of 10, the answer will be the same. Now for multiplying decimals, it's slightly different. The first step you want to do is turn it into whole numbers and multiply like that, but then you want to be mindful of what you've multiplied by. So to turn this into a whole number, I'd times 5.3 by 10 to get to 53. I'd need to times this. Well, if I times it by 10, it would be 7.25. If I times it by 100, it would be 72.5. If I times it by 1,000, that would be 725. So in total, I've multiplied this calculation by 10,000 to turn both of my decimals into integers, whole numbers. So then I'm going to do 53 times by 725. And again, you use whichever method you feel most comfortable with to get the multiplication done. I'm going to just use the lattice method because I like it and I think it's fun. So you divide it into 2, and then 5 times 5 is 25, 5 times 3 is 15, 2 times 5 is 10, 2 times 3 is 06, 7 times 5 is 35, and 7 times 3 is 21. Now I just add all my diagonals, so that would be 5. 5 plus 1 plus 6 is 12, so I carry the 1. 2 plus 1 plus 1 is 4. And then 5 plus 2 is 7, 8, and 3. So I know that 53 times by 725 is 38,425. Now, unlike decimals, that's not the same calculation. I don't get the same answer. What I have to do is think either, this is the shortcut method, you count how many digits are after the decimal point in your calculation. So there's 4 digits after the decimal point in your calculation. So you just say, okay, 1, 2, 3, 4. I'm going to put the decimal point there. So 5.3 times by 0.725 is 3.8425. Or the proper way, but you're probably just going to use a shortcut way, is this once is the calculation once it's been multiplied by 10,000, so you divide by 10,000. Shortcut way is probably the best bet for now. Okay, so in this question, we've got a few of the index laws. I'm being asked to write down 17 to the power of 0. Really quick recap. Let's just use a 2 power of 2. What do I do? Well, 2 squared is 4. 2 to the power of 1 is 2. Each time I'm dividing by 2, so I need to follow this pattern. Therefore, 2 divided by 2 is 1. And this is going to be the case for absolutely anything. So 17 to the power of 0 is 1. Anything to the power of 0 is 1. So that is a super easy mark. Anything to the power of 0 is 1. Next, we've got 7 to the power of minus 2. And what this means is you basically want the reciprocal. So imagine 7 without the minus is 7 squared. The reciprocal of that would be 1 over 7 squared. Okay, so the negative sign just says write it as 1 over itself without the negative. And I'm asked to write down the value of it, so I need to work it out. So that is going to be 1 over 49. Now for the next question, I'm told to write 27 times 3 to the power of 9 as a power of 3. So that means I need to write 27 as a power of 3. So what's a 3 kind of time? 3 to the power of 1 is 3. 3 squared is 9. Then 3 cubed is 27. So I know that 27 is the same as 3 cubed. So I then just do the calculation. When I am multiplying powers, so really quickly, like a to the power of 2 times by a to the power of 5 is going to be a2 plus 5. When you're multiplying, you add the powers, okay? So you add them. So that's going to become 3 to the power of 3 plus 9, which is 3 to the power of 12. Okay, so in this question, I've been given a Venn diagram, and I'm told that the universal set, this strange little squiggly symbol, just means the universal set. It means everything that can possibly be in the Venn diagram. So it's helpful to list out what that is. So numbers between 1 and 20 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, now the numbers that are in set A are multiples of 3 or 5. So let's start with the 3 times tables. That would be 3, 6, 9, 12, 15, and 18. And then the 5 times tables, well, that's 5, 10, 15, and 20. Okay, so in set A are going to be all of these numbers. And then set B is the factors of 20. So I could just do a quick little factor tree. So I know that would be 1 times 20, 2 times by 10, and 4 times by 5. So the factors of 20 are 1, 2, 4, 5. So 5 gets circled twice. So let's be mindful of that. 10, which also gets circled twice, and 20, which also gets circled twice. So the numbers that get circled twice are what are in the intersection. They are common to A and B. So I'm going to write 5 and cross it out just so I don't forget, 10 and 20 in this intersection here. Then everything else, all the numbers that are part of A, I've circled them in a different colour so I can conveniently just write them in. That would be 3, 6, 9, and let's cross them out, 3, 6, 9, 12, 15, and 18. And then the numbers that are just factors of 20, so they're the dark green ones, that would be 1, 2, 4, and is there anything else I've circled? No. So what that means is that all of the other numbers have to go on the outside. So I've got 7, 8, 11, 13, 14, 16, 17, and 19. Okay, in total there are 20 numbers. So you might just want to double check by seeing if there's 20 numbers in there. And that's how we'd fill out the Venn diagram. Now the next part is saying list the members of A union B. Now, really quick recap on probability notation. If you've got this, that means the union. So it essentially means in your Venn diagram, everything that is in A or B or both, okay? And I tend to sort of, just a silly little way to remember it, union looks like a valley. It doesn't really, but you can imagine it being valley. Valleys in this country are very common. So it's very common. So it means lots and lots of things can be present in it. The other type of notation is this, a intersection. So that is the intersect. So it essentially means anything that is in A and B. So it has to be in both of them. So that is just going to be anything in that little intersect there. So I am being asked to list the members of A union B, so everything that is inside here. So that would be 3, 6, 9, 12, 15, 18, 5, 10, 20, and then 1, 2, 4. Okay, so everything that's in that little bit there, that is the union. And then I'm asked or told a number is chosen at random from the universal set. The universal set just means everything in this Venn diagram. And I know that there's a total of 20 numbers, so I know it's going to be out of 20. This thing here, if you see P and then something, that just means the probability of and whatever's in the bracket. Now, the last thing about a set notation is if you see something like this, that means not. So the probability that it is not in B. So B is over here. So I want the probability that a number is not in B, so I can just cross those out. And then what am I left with? I'm left with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 numbers. So the probability of a number not being in B is 14 over 20. Okay, so next I've got a percentages question. I'm told that the price of a festival ticket increases by 30%, and the new ticket price adds £99 to the total cost of the festival ticket. So therefore, I know that 30% is equal to £99. Work out the price of the festival ticket before the price is increased. So if I know that 30% is equal to £99, what I can do is just find 10%. And how do I do that? Well, 30% divided by 3 gets me to 10%. So I'm going to divide this side by 3 too. So I know that 10% is £33. If I know that 10% is £33, I can then find what 100% would be. I'd multiply 10 by 10, because that gets me 100. So I have to multiply this side by 10 as well, and that would be £330. Okay, so in this question, there's quite a bit of information. Whenever you see anything in a question, please, can you just write down what you know about it before you panic? So especially worded questions, I know some people are just like, So what do you know about the mean? How do you find the mean? The mean is the sum of all the values divided by the number of values. Okay, so before we even start, we have that in the back of our mind. Now I'm told that a class has 27 pupils. All 27 pupils took a maths test, and there are 12 boys in the class. Okay, so first things first, if there are 27 pupils and there are 12 boys, that must mean that there are 15 girls. Okay, so you can just work out that little bit of information. The mean score of the class was 52. Okay, I've been given some information about the total mean. So 52 is the sum of all the class values divided by 27. So what I can do is, in order to find out what all of the class values were, I would do 52 times by 27. So 52 times by 27. 2 times 2 is 0, 4. 2 times 7 is 14. 5 times 2 is 10. 5 times 7 is 35. Add the diagonals, that will be 4, 10, 4, 1. So I know that the sum of all the class values is 1,404. I'm then told that the mean score of the boys was 42. So the mean, 42, equals the sum of the boys' scores divided by, and how many boys were there? 12. So I could do 42 times by 12. And then 2 times 1 is 0, 2. 2 times 2 is 0, 4. 4 times 1 is 0, 4. 4 times 2 is 0, 8. So add the diagonals, that would be 4. 8 plus 2 is 10. 4 plus 1 is 5. Okay, so the sum of the boys' scores is 504. Okay, now that I know what the sum of the boys' scores are, and I know what all of the scores add up to, I can work out what the sum of the girls' scores must be. So 1,404, take away 504, 4 take 4 is 0, 10 takes 0, 0 takes 0 you don't need to do, 4 take 5 you can't do, so that would become 14 take 5, which is 900. Okay, so now I know the sum of the girls' scores. I also know that there are 15 girls, so I can use my mean formula to find that out. So the mean is going to be 900 divided by 15. And remember, non-calculator, the little trick is you just keep on simplifying the fraction. So I could divide everything by 5. Again, if you're like, I don't like division, just use the bus stop method. How many 5s go into 9? 1, remainder 4. 5s into 40 are 8. 5s into 0 are 0. So that would become 180 divided by 3. And 180 divided by 3 is 60. So the mean score of the girls is 60. Okay, so a slightly tricky question. The likelihood is that you will get given the formula for pressure, but just in case, the formula for pressure is force over area. So I need to bear that in mind because this question is asking me to find the pressure. I've also been given a cone. Now the formula for a cone, if you just try to like imagine that you extended it and you turned it into like a cylinder, hopefully you can see that roughly you could fit, I mean, I've drawn this really badly, 3 cones into it. So what we do is we just say it's a third times by pi r squared, because that's the base, times by the height. So volume of a cone, you could rewrite it as pi r squared h over 3. You rewrite it in whatever way is best for you. So let's see what we can do. I know that's the formula for the volume of a cone. I've been told that the volume of the cone is 80 pi over 3 and it has a height of 5 centimeters. So how do I work out the volume of a cone? I can substitute my things in. I know that the volume, 80 pi over 3, is going to be equal to pi times by r squared, which I don't know, times by the height, divided by 3. So what I can do is rearrange it in order to figure out what r must be. Well, step 1, if I times both sides by 3, if I'm timesing something by 3 and it's being divided by 3, then it just cancels itself out, because that would become 3 times by this, and then 3 and 3 would cancel. So that would be 80 pi equals pi times by r squared times by 5. Then what I could do is divide both sides by 5. So 80 pi equals 80 divided by 5. My brain is very tired. 5s into 8 go once, remainder 3. 5s into 30 are 6. Okay, so 16 pi equals pi r squared. So therefore, and you don't need to do this really, r squared is 16 and the radius is 4. But all you need to know is the area of the base, because whenever we're dealing with pressure, you're doing the force divided by the area that comes into contact with the surface. So that's just the base of the cone. So you could have just left it as 16 pi because you know that is the area. But if you needed to, you could have worked out the radius and then just done pi r squared and you'd get back to 16 pi. So I know that the area of the base is 16 pi centimeters squared. So thank you, volume of a cone, for that piece of information. So the area is 16 pi centimeters squared, and I am told that the cone exerts a force of 160 newtons. And how do I work out pressure? Well, pressure is force, which is 160, divided by area, which is 16 pi. So if these kinds of things confuse you when you've got a fraction like this, you can just split it up into 2 fractions. So the numerical part and the random pi part. So you could just split that up like that, because as long as they're being multiplied, you can split the fractions up, because multiplying fractions, what would that turn back into? It would turn back into this. So you can split them up just to make it a little bit easier for yourself. 160 divided by 16. Once again, if you don't notice that it's 10, then what would you do? 160 over 16, you divide by 2, so that would be 80 divided by 8, and then hopefully you notice it's 10. Don't panic. If you get something like this and your brain just freezes, just simplify with the fractions. So that would give me 10 over 1 times by 1 over pi. So that would be 10 over pi. Now, this kind of question, let's just write that. So 10 over pi centimeters squared is the pressure. And sometimes people are like, oh, this question is super hard, or it's doing difficult things, so I can't do it. But just do as much as you can and try and think of the simple multiplication division tricks that you can use to help you. And a key knowledge of fractions is really, really vital for so many of these. But hopefully that helped. Okay, so in this next question, I've been given a graph and told to solve the simultaneous equations. Now, they want you to do this graphically. Don't try solving them. Just look at the graph. And the way that you solve simultaneous equations graphically is you literally look for the point where the two lines intersect. So all I need to do is try and find the coordinate of that point. Where do they intersect? Over here at the coordinate -1, 1. And every coordinate is written x and then y. So x equals 1 minus 1 and y equals 1. And that is literally all you have to do. Whenever you're solving anything graphically, just look where the lines intersect. Okay, so in this question, I've been told that circle A has a diameter of 20 centimetres. Circumference of circle A to the circumference of circle B is in the ratio 2 to 5, and I then need to work out the area of circle B. So in this question, it's really helpful to think back to the formula for a circle's circumference and area. So the formula for the circumference of a circle is pi times by the diameter. This is also going to be on your formula sheet, so you can use that if you don't know this off by heart. And the formula for the area of a circle is pi times by the radius squared. So it's just really helpful to just write out the things that you know so that they can help you in the question later on. So I know that the circle A has a diameter of 20 centimetres. How do I find the circumference? Well, the circumference is going to be pi times by the diameter. So the circumference of circle A is 20 pi. I know that the circumference of circle A to circle B, so A to B, is 2 to 5. So if the circumference of circle A is 20 pi, that must mean that the circumference of circle B, what have I done to 2? I've multiplied it by 10 pi. So I'm going to have to do the same on this side. So the circumference of circle B would be 50 pi. So I know the circumference of B is 50 pi. Now, how do I find circumference? It's literally pi times by the diameter. Therefore, I know that the diameter of B is 50. Now, I need to work out the area of the circle, and in order to work out the area of the circle, I need to find what the radius is. The area is pi times the radius squared. Now, just as a quick recap, the radius is the line from the centre of the circle to the outside, and the diameter is a line from one side of the circle to the other going through the centre. So a diameter is 2 lots of the radius. So now that I know that the diameter is 50, I know that the radius of circle B is going to be 25 centimetres. So I can use that in my formula and find the area, and I leave my answer in terms of pi, so I don't need to worry about pi. So what am I going to have to do? I'm going to have to do pi times by 25 squared. So really quickly, 25 times by 25, you can multiply this however you like. You might also know that it's 625 because you're great at your square numbers, but if not, then 5 times 2 is 10, 5 times 5 is 25, 2 times 2 is 4, and 2 times 5 is 10. Extend your line, so that'll be 5, 2, 6. Okay, so I know that the area is going to be pi times by 625, which is 625 pi. So all of these things you know how to do. It's just about recognizing what formulas do you already know and how can you use them in these questions. And that's how you need to attack all of the questions. What do you know and what can you use? At least you can pick up some marks for some of the simpler things. Okay, so here I've been told that I have a sector of a circle with radius 3 centimetres and an area of 1 4/5 pi. I need to work out the size of the angle XYZ. Well, what are the formulas that I know for sectors? I know that the area of a sector is theta, which represents the angle, over 360 times by pi r squared. And the reason for this is you're just saying what fraction of the circle am I working out? Like if I had to work out a quarter of the circle, I would use the formula pi r squared and I'd divide it by 4, which is the same as multiplying by a quarter. So we're always just trying to figure out the fraction of the circle which is this, and then we multiply that by the area of the whole circle. So let's fill out the information I know. I know that 1 4/5 pi is the area. So just to make life easier, I can turn it into an improper fraction. 5 times 1 is 5 plus 4 is 9. So 9/5 pi is the area of the sector. And I know that theta over 360 times by pi r squared. Do I know the radius? They've told me that the radius is 3 centimeters. So I'd say 9/5 pi is theta over 360 times by 3 squared is 9. So that would be 9 pi. So let's simplify that a bit. 9 pi over 5 is equal to theta times by 9 pi over 360. And I've just simplified that because that would just be 1. So I can bring the numerators together. What can I now do? Well, I can multiply it by 360. So 360 times by 9. So 360 times by 9. 9 times 0 is 0. 9 times 6 is 54. And 9 times 3 is 27. Add the 5 is 32. So that would give me 3,240 pi over 5 equals theta times by 9 pi. There are loads of ways that you can continue this. You just do whichever method works best for you. I could first of all simplify 3,250 divided by 5. So let's start there. So 3,240 divided by 5. 5's into 3 don't go. 5's into 30 is 6, remainder 2. 5's into 20 is 4, remainder 4. And 5's into 40 is 8. So let's rub that working out from, something strange has happened. Why has my slide gone? So my slide just strangely disappeared there, but let's continue. So 3,240 divided by 5. 5's into 32 go, I already did this, didn't I? Okay, anyway, 5's into 32 go 6, remainder 2. 5's into 20 go 4, remainder 4, and 5's into 40 go 8. So I'm left with 648 pi equals theta times by 9 pi. So what could I do to find out theta? I can divide both sides by 9 pi. So that would get me 648 pi divided by 9 pi equals theta. Pi divided by pi cancels out, and then I'm just left with 648 divided by 9. 9's into 6 don't go. 9's into 64 go 7, remainder 1. And 9's into 18 go twice. So therefore theta is 72 degrees. Remember, theta is just another, it's a mathematical symbol for an angle. So theta is 72 degrees, or you could say angle XYZ equals 72 degrees. Okay, for the next part, I haven't actually read this yet. Let's see. So the ratio PY to XY is 2 to 3. Okay, so I know that XY is 3. So PY is going to have to be 2. That's quite a nice ratio. Okay, so I know that the length over here is 2 centimeters. And I need to calculate the size of the shaded area. Okay, so what am I going to need to do there? I'm going to need to use the area of a sector formula. So what was that again? It was theta over 360 times by pi r squared. Now I know that my angle I've worked out is 72 degrees. So let's just see if we could simplify that. 72 over 360 is the same as 36 over 180 if you just divide by 2, which is the same as 18 over 90, which is the same as 9 over 45, which if I divide by 9 is 1 over 5. Okay, so I can just make life easier by simplifying that fraction. You don't have to. So I know that so the area of the sector is going to be 1/5 times by pi r squared. And now I just need to work out what the radius is. So the shaded area is going to be the area of this whole sector minus the area of this little sector here. They both have the same angle, so I can multiply both of them by 1/5. So area of big sector is going to be 1/5 times by pi r squared. If the fifth thing is confusing you, just use 72 over 360. I just did it to simplify the numbers. 1/5 times by pi r squared. Well, this long radius here is 3. So that would be 1/5 times by 9 pi. So that would be 9 pi over 5. And the area of the small sector is going to be 1/5 times by the radius was 2. So 2 squared is 4, so that would be 4 pi over 5. And how do I work out the shaded area? I do the big area, take away the smaller one. So I'm going to do 9 pi over 5, take away 4 pi over 5. Whenever you add or subtract fractions, they need to have the same denominator, so I'm super lucky that these do. And that would just give me 5 pi over 5. And actually, if I simplified that, that would just leave me with pi. And I could write pi centimeters squared. Okay, so in this question, I've been given a table and I've been asked to draw a cumulative frequency graph, and it's about the weights of 40 koala bears. So they're cute. Okay, so in order to draw a cumulative frequency graph, you need to actually find the cumulative frequency. So that can be the first thing that we do. And cumulative frequency is just the running total. So there are 5 koala bears. And actually, I'm just going to write it here so that it's a bit bigger because that's quite small. So the cumulative frequency is going to be 5 to begin with, because there are 5 bears between 0 and 3 kilograms. And then I add on 10, so that would be 15. And then I add on another 15, so that would be 30. And I know that there are 40 koala bears in total, therefore this must be 10. So my final cumulative frequency would be 40. Okay, cumulative frequency just means the running total, so you just add on everything that's come so far, because in total, I'm saying that between 0 and 12 kilograms, there are 40 koala bears. Now, to plot your cumulative frequency, you always use the end point of the class interval. So the coordinates would be 3, 5, and then 6, 15, and then 9, 30, and then 12, 40. And when I'm plotting, be really careful of the scale. Sometimes they're really nice, sometimes they're not. So just think to yourself, what's the difference between 0 and 5? Well, that's a gap of 5. And how many little squares are in between that? 10. So that means each little square is worth 0.5. So the first coordinate is 3, 5. So that would be 2.5. So 3 would be just 1 square up. 3, 5 would be here. Then I've got 6, 15. So 6 and 15. Then 9 and 20. So 9 and 20. And then my final one is 12 and 30. So it's a little bit of a, in the exam it will be a lot better. I had to make this quite quickly. So the graph isn't great, but we can still use it. So I've drawn the graph, and now I need to find the interquartile range. So with a cumulative frequency, and even with a box plot, you have your largest value, your smallest value, but then you have this section in the middle. So the median is always going to be 50% of the data. So there are 40 koala bears, so the median would be at 20. The upper quartile is the top, is where the 75% of the data is, and the lower quartile is where 25% of the data is. So to find the interquartile range, you are literally finding the difference between the upper quartile and the lower quartile. So we just do upper quartile, take lower quartile, and that will tell me the interquartile range. So what is 75% of 40? 3/4 of 40 is 30. So I go along to 30. Ooh. Hold on, something's not right. Oh, I should have plotted it at 40. Yep, so that would be a steep rise to 40. Okay, right. Anyway, interquartile range is 30. I go along the graph and then I go down. So let's just say that's 12.5. And then the lower quartile is going to be a quarter of the data. So a quarter of 40 is 10. So I go across to the graph and then down. So that would be 4.5. And the difference between 12.5 and 4.5 is 8. So the interquartile range is 8 kilograms. The next part of the question is saying estimate the number of koalas that may weigh more than 8 kilograms. So I'm going to use the other axes now, the weight axes, and I'm going to just mark a point at, that would be 7.5, so 8 is just going to be here. And then I go and I read across, and that is about 16. So how many koala bears weigh more than 8 kilograms? It's going to be all of these koala bears. Okay, so from 16 to 40, that's a difference of 24. So 24 of the koala bears weigh more than 8 kilograms. Okay, so this is an exact trigonometry question, and in order to work out your exact values, you just need to remember two triangles. So I won't go into the ins and outs of it, but this would be a triangle of side 1, this would be a triangle side length 2, and that would be square root of 3. So that is if you're using a 30-degree angle or a 60-degree angle. The one I'm interested in is a 45-degree angle, so I form an isosceles triangle that has 45 degrees. And the side length is 1 and 1, and this is root 2. If you want to know exactly how and why these triangles come about, watch the full video on exact trigonometric values. But for now, we're just going to go with this. These are the triangles you need to remember. So I am trying to work out sine 45. So if this is my angle, then I can label my triangle. This is going to be the adjacent, this would be the opposite, and this is the hypotenuse. How do I find sine? Well, sine theta is, if I write out SOHCAHTOA, always do that just to remind you, sine theta is the opposite over the hypotenuse. So therefore, in this case, the opposite is 1 and the hypotenuse is root 2. So the exact value is 1 over root 2. Next, I am told that cos 60 is 0.5. I could have worked it out using the triangles, but they've given it to me, so that's really nice. So now I need to work out the value of x. So this is just a basic trigonometry question. So SOHCAHTOA. I'm going to label my triangle. So this is my given angle. I'm trying to work out x. This is the adjacent. That would be the hypotenuse, and this would be the opposite. So which two sides have I been given? I'm dealing with the hypotenuse and the adjacent, so I would use CA. So I write out cos theta equals adjacent over hypotenuse, and it's really helpful to just write it out, just because the amount of silly mistakes you make under the pressure is mad. So just write things out and take it slow. So let's substitute what I know. I know that the angle is 60 degrees. The adjacent is what I'm trying to find, and the hypotenuse is 12. So all I need to do is say 12 cos 60 equals x. And you might think, this is a non-calculator paper. Yes, you'd be right. But that's exactly why they've told you that cos 60 has the value of 0.5. So I can rewrite that as 12 times by 0.5, because I'm just replacing cos 60 with 0.5. So 12 times 0.5, well, 12 times by a half is the same when you're multiplying by a half or 0.5. So times by 0.5 or a half is the same as dividing by 2. Just a quick little non-calculator exam tip. So x is going to be 6. And that's how I do that. Okay, so here I'm asked to prove algebraically that this recurring decimal has the value of 8 over 55. So I always start by calling my decimal x. So x has the value of 0.145, and the 4 and the 5 are recurring. What I want to do is keep multiplying it so that I get rid of anything that is not recurring. So if I multiply it by 10x, then I end up with 1.45 recurring. Now I've got the recurring part on its own after the decimal point, and that's exactly where I want it. And I need to multiply it by another power of 10 so that I also have another 0.45 after it. You can do this step by step. You know that 100x is going to be 14.54 recurring, so that doesn't match up. So you times it again. So 1000x is 145.45 recurring. And now you can see that you've got these nice bits where the bit after the decimal point is recurring, which means that if I subtract it, it will become 0. So over here, I can just circle my chosen values. I know that 1000x is 145.45 recurring. And I also know that 10x is 1.45 recurring. And what I can do is just subtract them, because if I subtract them, I get rid of this recurring decimal point and I make life very pleasant. So 1000 take away 10 is 990x. And 140, well, this and this is going to cancel. So 145 take away 1 is 144. So I could rearrange that and say x is 144 over 990. Now I know it's going to simplify, so let's just do what we'd normally do. Okay, so I've got 144 over 990. Now I just need to simplify. So I could start by dividing by 2. Whenever you're simplifying, you always try dividing by 2, then 3, then 5. You just essentially use the prime numbers. So let's try 2. 144 divided by 2 is 72. 990 divided by 2 is going to be 495. If you can't do that in your head, and just to be safe, you could just use the bus stop method. Just bus stop method is your favorite friend. Okay, so now let's see what I can divide this by. Well, I'm going to try 3. So 3's into 72, 3's into 7 go twice, remainder 1, so that would be 24. And then 3's into 495, 3's into 4 go once, remainder 1. 3's into 19 go 6, remainder 1. And 3's into 15 go 5. So that'd be 24 over 165. Now, what can I divide by again? Well, 3 maybe. So let's see, 3's into 165 is 3's into 15 go 5 times, remainder 1, and 3's into 15 go 3. So go 5. My goodness, what is going on with my mental maths? So that would be 55, and 24 divided by 3 is 8. Okay, so when you have a question like this, you need to prove it algebraically. So you do all the algebra stuff, but then you also have to show how it simplifies. It's not good enough to just say 144 over 990 equals this. You need to show the process of simplification, at least like simplify it once. And you also need to show what you simplified it by. So just take your time and double check everything and use the bus stop method to help you. Okay, so Dora decides to go on a road trip to the seaside. She lives in Cambridge. She leaves Cambridge at 8 a.m. on the Saturday morning. She drives 40 miles per hour for 30 minutes, stops at a service station to grab some breakfast. She's there for 45 minutes, then drives 60 miles per hour for 150 miles. I need to work out what time she arrived and the total distance she travelled. So what's the formula for speed, distance and time? Speed equals distance divided by time, and therefore distance is speed times time, and so forth. Okay, so let's figure some stuff out. So she drives for 40 miles per hour for 30 minutes. So I know the speed and I know the time. So I want to work out the distance. How do I work out distance? Distance is speed times time. So I do 40 times, and this is where so many people get caught out. Time also always needs to be written, unless the question is specifically meters per second or whatever, which it very rarely is. Always write it in units of an hour. So 30 minutes, and how do you write it as a unit of an hour? Whatever the minutes are, you write it over 60. 30 divided by 60, and then you simplify. So 30 over 60 is 0.5. So to work out the distance, I'm going to do 40 times by 0.5, and timesing by a half, remember, is the same as dividing by 2. So 40 times by 0.5 is 20 miles. So she drives 20 miles. She then stops at a service station to grab some breakfast. So there's two things I need to be working out. One is like the time. So I can set up a little column here. This is going to get a little bit messy. So time. And then I also need to work out the total distance. So the time, she leaves at 8 a.m. She drives for 30 minutes. So that will be 8:30 a.m. She then stops at a service station and is there for 45 minutes. So 8:30 plus 45 minutes is going to be 9:15 a.m. And then drives for 60 miles per hour for 150 miles. So in terms of distance, she travels 20 miles. Then she stops, so she doesn't travel any distance. And then she travels 150 miles. So the distance part is pretty simple. Total distance is 170 miles. And then I just need to work out the total time, which I can work out by using this. So how do I work out time? Let's just get rid of some of this. Time, if I rearrange the formula, switch these two around, time is distance divided by speed. So I have been given the distance, which is 150, and the speed, which is 60. So let's simplify that. Divide by 10 would be 15 over 6. And 15 divided by 6, once again, use the bus stop method if you're stuck. So whenever you know that it's going to be a decimal, you just add a bunch of zeros, put the decimal point down and add a bunch of zeros, and that's where your remainders go. So 6 is into 15, go twice, remainder 3, so I put my decimal point there, and 6 is into 30, go 5 times. So I know that that is 2.5 hours, which is 2 hours and 30 minutes. So 9:15 plus 2 hours is going to be 11:15, and plus 30 minutes is 11:45 a.m. So the total time it took her is it's not asking when she arrived, it's asking for the total time. So from 8 to 11, we go 9, 10, 11. So 3 hours and 45 minutes. And that's how we do that. So you just break up the question and work out each little bit by bit. Okay, so next I'm told that solid A and solid B are similar cubes. Similar is super important because it tells me that they are enlarged by a common ratio. So the height of solid B is 4/5 the height of solid A. Okay, so I know that they're cubes. And whatever solid B is, so this is solid A, so I could say that's X. And solid B, its height is going to be 4/5 X. I'm told that the volume of solid A is 125 centimeters cubed. Find the surface area of solid B. Okay, so let's see what we can do. I know that X, well, how do you find the volume of a cube? You work out the area of the cross section, which would be X times X, and then you multiply it by the length. Like you imagine the cross section is the bit you can push through the whole shape. So that would be X times X times X, which is X cubed. So I know that X cubed is 125 because they've told me that. Therefore, X is going to be the cubed root of 125. And hopefully you know your cube numbers. The cubed root of 125 is 5. So if solid B has a height that is 4/5 the height of solid A, then its height is just going to be 4, because 4/5 times by 5 is 20 divided by 5, which is 4. So I know that the height of solid B is 4. And I need to find the surface area. Now, how do I find out the surface area? Every cube has 6 faces. So this is for cubes and for cuboids. So if you imagine all the faces, you've got the front face and the back face. Then you've got the side face here and the side face here. And then you've got the base and the top. So I know that a cube has 6 faces. You can also imagine it as a net. So like if you unfolded the cube, it would look like this. You'd like fold it back up. So a cube has 6 faces. I know that the side length is 4. Okay, so therefore each individual face has an area of 16 centimeters squared. I know that there are 6 identical faces. Also, the fact that it's a cube tells you that each of the sides are going to be equal. So I know that there are 6 identical faces, so I'm just going to do 6 times 16. I could do this using normal multiplication, or another really good non-calculated trick is the doubling and halving. If you double one part of the calculation, so let's double that to 32, and you halve another part, you end up with the same answer. So 3 times 32 is a little bit easier to do in your head. That would be 96. And just, you could have done it the other way. You could have doubled this, 12 times 8. That is also 96. So 6 times 16 is 96. So the surface area of solid B is 96 centimeters squared because it's an area. Okay, so here I've got a probability question. I'm told that the probability that Dasha makes it to work on time is 0.2. And the probability that she buys a coffee on the way to work is 0.9. And I need to find the probability that she arrives late with a coffee in her hand. So she's arriving late and she has a coffee in her hand. So the first thing I want to do, I know that the probability of her being on time is 0.2. So I want to work out the probability that she arrives late. Well, this is, with probability, your probabilities have to sum to 1. So the probability of her being on time is 0.2. The probability of her arriving late is going to be 1, take away 0.2, which is 0.8. Probabilities must always sum to 1 if it's of like an event happening and not happening. So the probability that she arrives late is 0.8. The probability that she gets a coffee is 0.9. I need to work out the probability that she arrives late and has a coffee in her hand. So when I do this, I'm dealing with independent events. She could get a coffee and arrive late. She could get a coffee and arrive to work on time. That's separate to her arriving on time. It's not saying if she gets a coffee, the probability she arrives to work late is this. So it's not dependent, it's independent events. So they're treated separately. And using the AND rule, all I do is multiply probabilities. So that's why on a probability tree, when you are finding something, let's say that's A and that's B, to work out the probability of A and B happening, you multiply along the branches. So let's just do that. I have to do 0.8 times by 0.9. So using the decimal trick, I turn the numbers into whole numbers. So 8 times by 9 is 72. And I know that in order to turn it into a decimal, when I'm multiplying, what have I done? I've times 8 by 10 and I've times 9 by 10. So I'm going to have to divide by 100 to get back to it. Or the quick trick is, I know the digit's going to be 72. There's 2 digits in my calculation after the decimal point. So I know my answer is going to have 2 digits after the decimal point as well. So that would be 0.72. And that is my answer. Okay, so in this question, I've been told line A has the equation of y minus 2x is 5, and that line B is perpendicular to the line. They both go through the point of 4, 3, and I need to find the equation for the line B. Now, every straight line can be written in the equation y equals mx plus c, where m, it represents the gradient, so the steepness of the line, and c represents the y-intercept. So I need to find the gradient and the y-intercept. Now, first things first, if you get an equation and it's not written in the form y equals mx plus c, just to rearrange it. So y minus 2x equals 5. I'm going to rearrange it so that y is the subject. So I add 2x to both sides, and I'm left with y equals 2x plus 5. So I can find the gradient. So the gradient of A is 2. And a key thing you need to know about perpendicular lines, the gradients of perpendicular lines multiply to make -1. Another way of saying this is they are the negative reciprocal of one another. So what does that mean? A reciprocal, so let's just use 3. The reciprocal of 3 would be a third. It's like the inverse of it. So why is that? 3 as a fraction would be 3 over 1. The reciprocal, you just flip it. And the negative reciprocal, if you've got a positive number, the negative reciprocal would be minus a third. If you have a negative number, so the negative reciprocal of minus 2 would be a half, because you have to multiply them. So they need to multiply to make negative 1. So if I know that fact, then 2 times by something must make minus 1. That something is the negative reciprocal of 2. So I turn it into its reciprocal. You can always just imagine it as a fraction if that helps. And I'm going to stick a minus sign in front of it. Therefore, the gradient of line B is minus a half. So I can just start by writing this. And this is the first part of my equation for line B. I then need to work out the y-intercept. That's going to be a little bit trickier, but in this equation where y equals mx plus c, the y and the x, these just represent the coordinates at any given point. Now I've been given the coordinate 4, 3, so I know that the lines both go through this point, so therefore I can substitute x equals 4 and y equals 3 into this equation. So if y is 3, 3 must equal minus a half times by x plus c. So let's simplify that. Minus a half times by 4 is minus a 2 plus c. So to rearrange it and get c on its own, I add 2 to both sides. So 3 plus 2 is 5, so c must equal 5. Therefore, the full equation of the line is going to be y equals minus a half x plus 5. And that's how you do a perpendicular question. If the question was the same but parallel, you just know parallel lines have the same gradient. And remember to always use the point and substitute it into your equation. Okay, so here I've got 2 different ratios that have one variable in common. So what I can do is I can write them in the way that I want them to finally be, x to y to z. So I know that the ratio of x to y is 2 to 3. Then I know that the ratio, and this is where it gets, this is not a simple standard kind of combining ratio questions. I know that the ratio of 2y to z is 4 to 5. So 2y is equal to 4. Therefore, if 2y is 4, y must be 2. So the ratio of y to z is going to be 2 to 5. Okay, so then I know the ratio of y to z is 2 to 5, and I can write it in this table here. In order to combine the ratios, you want your common variable, in this case this, to be equal. So you find the lowest common multiple of the variables. The lowest common multiple of 3 and 2 is 6. So I multiplied this ratio by 2, and that is going to be 4, and that is going to be 6. And then I multiplied this ratio by 3, because 2 times 3 makes 6, and then 5 times 3 makes 15. So x to y to z would be 4 to 6 to 15. Okay, so dealing with standard form, when you've got a question like this, there's a few things that you can do. So 2.1 times by 10 to the power of 7 is being divided by 3 times by 10 to the power of minus 5. Now what we can do, because remember that divide sign is this divide sign here, it's just another way of writing it. When you've got fractions, if their numerators are a product and their denominators are a product, you can separate them. So I could separate that into 2.1 over 3 times by 10 to the power of 7 over 10 to the power of minus 5. And then it just makes it a little bit easier for me to see what I'm doing. So I need to do 2.1 divided by 3. So how many 3's fit into 2? 0. I've run out of numbers, so I put the decimal point and I carry the 2. How many 3's fit into 21? 7. So I know 2.1 divided by 3 is 0.7. Then I do the standard form. Now what do you do when you divide indices? Well, the law of division is that whatever this is, you subtract the powers, okay? So when you're dividing indices, you subtract the powers. So I'm going to need to do 10 to the power of 7 take minus 5. And when you're taking away a negative, you add them. So that would become 10 to the power of 12. So 0.7 times by 10 to the power of 12. I haven't finished yet though, because they have said, write your answer in standard form. So for it to be in standard form, it needs to be between 1 and 9.9 times by 10 to the power of something. So I need to times this by 7. Okay, so I've multiplied 0.7 by 10 in order to turn it into an integer so it can be in standard form. And because I'm timesing by 10, I then divide by a power of 10 on this side. So that will become 10 to the power of 11. Because each of these little powers, what does 10 to the power of 12 mean? It means 10 times 10 times 10, 12 times. So if I've times part of the calculation by 10, I need to divide the other part by 10 to keep it the same. So in standard form, that would be 7 times 10 to the power. Okay, so a changing the subject question. Now these questions, I cannot stress enough, just keep doing things until something makes sense, because all you need to do with a question like this is just move things from one side to the other, maybe factorize, and maybe do a couple of things. So step 1, whenever you have a fraction, you're generally going to want to multiply by the denominator. So I am going to multiply both sides by 4x plus 2. So I'd be left with y brackets 4x plus 2 equals 3 brackets 2x minus 8. And always bear in mind it is x that you're trying to make the subject of the formula, so you want to end up with x equals. So what I could do is first I could expand the brackets. So I'd be left with 4xy plus 2y equals 6x minus 24. Now, I've got x on both sides of the equation, and I've got x in terms that are not like terms. And if this happens, this is where it's a key sign that all we need to do is factorize. So let's bring the x terms onto one side, and then we can factorize. So if I first subtract 6x from both sides, I'd be left with 4xy, take 6x, plus 2y equals minus 24. And then I could just move the y. So I'd be left with 4xy minus 6x equals minus 24 minus 2y. And then I can factorize. So I want to factorize the x out so the x can be on its own. So that would be x on the outside, 4y take away 6 equals minus 24 minus 2y. And then the last final step would just be to say x equals minus 24 minus 2y over 4y take 6. It's not the nicest of fractions, but we have made x the subject of the formula. One little extra bit actually, this is quite ugly, and generally they're not going to want you to have like a negative numerator. So if you get a situation like this, I'll just show you why this works. So if, let's say, x was minus 8 over 2. What is my answer? Minus 8 divided by 2 is minus 4. Now, if I multiplied each part of the fraction by negative 1, I end up flipping it. So that would be 8 divided by minus 2. But that doesn't affect the end result because my end result is still minus 4. So what I can do in a situation like this is just times everything by minus 1. So x would be 24 plus 2y over, well, it would be negative 4y plus 6. So what I could then do is just rearrange it, 2y plus 24 over 6 minus 4y. It doesn't really matter which one comes first, but it's just nice to not have a negative at the beginning. So that is just one final little tip. Okay, so in this question, I've been given a shape and I've been asked to enlarge it by scale factor minus a third. Okay, so if you get a minus scale factor, it reverses the direction. Okay, so normally when we're doing enlargements, we have our center of enlargement, let's say it's here, and then we're like, how do I get from here to there? How do I get from my center of enlargement to the shape? And then you like enlarge it like that. But what we're doing when we reverse the direction is we start from the shape and go towards the center of enlargement and beyond. So we're essentially reversing the direction. So let's first plot our center of enlargement, minus 1 over here. And what I want to do is think to myself, okay, I've got 3 vertices, 3 corners of this shape. So let's start with this corner. What am I doing to get to the center of enlargement? Well, I'm going from 2 to -1. So I'm going 3 down and 3 across. So what I'm going to do, because it's a third, you do whatever your distance is from your point, you multiply that by the scale factor. In this case, it's a third. 3 times a third is 1. So I'm going to go down and across 1 and plot that point there. That's x. Then I'll do it with another x in a different color. So what do? I go 3 down and 6 across. So I'm going to have to go 1 down, and 6 divided by 2 is 2 across. So that would be where my other point is. And this point here, from 8 to -1, is 9. So I go 9 down and 3 across. A third of 9 is 3. So I'm going to go 3 down and 1 across. And then I just join my points together, and it says label your image B, so just give it a little B. Okay, but the key thing is the scale factor tells you how much larger the shape is or smaller, and the center of enlargement is, if it's a negative, you start from the shape and you go to the center of enlargement. If it's a positive, you start from the center of enlargement and you go towards your shape. Okay, so in this question, I'm told that y is inversely proportional to the cubed root of x. So whenever I'm dealing with inverse proportion, the inverse is like 1 over that thing. So this is my statement of proportionality. If you just remember the equations, that's absolutely fine. So either of these is absolutely fine. We generally start with the equation. So the equation for inverse proportion is k over x. In this case, it's cubed root of x. Really quickly, I'll just write it down. If it's direct proportion, you would use the equation y equals kx. If it's inverse proportion, it would be y equals 1 over, or k over x. Okay, so one is being multiplied, one is being divided. So I know that my formula, when I find the value of k, is going to be k over the cubed root of x. Now I've been given some information. I know that y is 7/3, so 7 over 3 is equal to k over the cubed root of, and the value of x is 27. Hopefully you know your cube numbers, they're super important. So 7/3 is going to be equal to k over the cubed root of 27 is 3. How can I find k? Well, I just multiply both sides by 3. So essentially I'd be doing 3 times 7. So k has the value of 7. If that is confusing, then actually just multiply it. 21 divided by 3 would also give you 7. So I know k is 7, and then I can use that for a general formula. So if k is 7, then y equals 7 over the cubed root of x. This is my general formula that I can use to work out any term. So I need to find the value of y when x is 64. So y is going to be 7 over the cubed root of 64. And what is the cubed root of 64? 4. So 7 over 4. And it's asking for the value, so I don't know whether it means decimal or fraction, but let's just do 7 divided by 4 just to be sure. 4s into 7 go once. I run out of numbers, so I'm going to put zeros. Remainder 3. 4s into 30 go 7, remainder 2, and 4s into 20 go 5. So 7 over 4 is 1.75. Okay, so here I've been given a nice third question. It's going to be rationalising the denominator, because generally with thirds, you never want to leave a third, an irrational number on the bottom of the fraction. So what we do, really quickly, base level explanation, if you had something like this, 7 over the root 7, to rationalise the denominator, you would just multiply it by root 7. So these ones are super easy because you just times it by whatever the denominator is. So that would be 7 root 7 over 7. The 7 and 7 would cancel, so that would just be root 7. However, when we have a slightly more complicated denominator, what we do, so we've got 4 minus root 12 over root 3 minus 1. If I just multiplied by root 3, I wouldn't cancel out the third. So what I do is I multiply by the inverse of this. So instead of root 3 take 1, it's going to be root 3 plus 1. And the reason I do this is very simple. Like if I'm expanding brackets, let's say you had x plus 3 and x minus 3, that would become x squared plus 3x minus 9. So the x terms, they'd cancel out, just like the third terms in this case are going to cancel out. And that's the whole point of rationalizing. You're trying to get an integer as your denominator. So once we do that, we just multiply. Now, when you're multiplying, it's just like expanding brackets. So that would be 4 minus root 12 times by root 3 plus 1. So we'll do the numerator first. So that would give me 4 root 3 plus 4, and then really quickly, so when I'm multiplying thirds, what you do, actually let's just do it as a general rule, if you're doing a times b, you just bring them together as ab, so it's the product of the two. So root 12, or negative root 12, times by root 3 is going to be negative root 36. 12 times 3 is 36. So negative root 12 times by negative root 3 is going to be minus 6. Then I do negative root 12 times by 1, which is just negative root 12. Okay, I'm going to want to simplify that. So always, when you've got thirds, you want to simplify them. Now, when you're simplifying a third, so in this case, we've got root 12, what we do is we say to ourselves, okay, I want to find two numbers that multiply to make this number, and ideally one of them is going to be a square number. So your square numbers are 1, 4, 9, 16, 25. It's going to be one of them. So 4 times by 3 makes 12. Now I could write that as root 4 times root 3. It's the same thing if I follow this rule. And what is the square root of 4? That is 2. So root 12 would simplify to 2 root 3. So I'd write this as 4 root 3 plus 4 minus 6 minus 2 root 3. Then I could collect the integers. So that would be 4 root 3. 4 takes 6 is minus 2 root 3. And then when you're simplifying thirds, so as in when you're collecting the like terms, you can just treat them like algebra. So 4 root 3 is the same as, take away 2 root 3 is the same as saying 4a minus 2a. What would that give you? It would be 2a. So therefore 4 root 3, take 2 root 3 is going to be 2 root 3, and you're left with a minus 2. So your numerator simplifies to 2 root 3 minus 2. Now we need to deal with the denominator. So let's have a look. We've got root 3 minus 1 multiplied by root 3 plus 1. Root 3 times by root 3. Another quick fact that you should hopefully know, but if not, then a third multiplied by itself is its unsurd self. So quick example, the square root of 25 times by the square root of 25. I know that the square root of 25 is 5, and I know that 5 times 5 is 25. And therefore, any third multiplied by itself, you get rid of the square root sign essentially. So square root of 3 times square root of 3 is just 3. Square root of 3 times by 1 is square root of 3 minus square root of 3 minus 1. And that is why I do the conjugate, the inverse, because these two terms cancel out. So I'm just left with 3 minus 1, which is 2. Okay, so I've got this fraction and I need to show that it can be written in the form, okay, so I need to show that it can be written in the form a plus b root 3. So once again, what can I do? Well, I can write these as two separate fractions just to make life easier for myself, because remember, if you're adding or subtracting fractions and they have the same denominator, you can bring them together. So this and this would simplify to the same thing. It just makes it a little bit easier to see what you're doing. So 2 root 3 divided by 2 is just going to leave you with root 3 over 1. Take away, and 2 over 2 is 2 divided by 2 is just 1. So that is the same as saying root 3 minus 1. And in this case, don't worry if it says a plus, it can also be a minus because you can add a negative. So a isn't an integer, but if it was, it would be 1 root 3 minus 1. although they have said in the form a plus b root 3, so just to be technical, we'd say -1 plus root 3, and that would be our final answer. Okay, so a functions question, and functions, please don't be scared of them, especially the first type where you're just literally substituting into an expression. So I'm told for x is greater than or equal to 0, the functions of f and g are such that f of x is 2x plus 3 and g of x is cubed root of x plus 3 over 4. I need to find g of 64. All that means is you substitute 64 into anywhere you see the value of x. So g of 64 is going to be the cubed root of 64 plus 3 over 4. What's the cubed root of 64? 4. So I'm left with 4 plus 3 over 4. 4 plus 3 is 7. 7 divided by 4 is 1.75. Okay, the next part is inverse, the inverse of g. So what we do when we're finding the inverse, there are a few steps that we need to take. So instead of saying g of x, we call it y. So we say y equals the cubed root of x plus 3 over 4. And then what you do is you switch your x and your y variable. So x would be the cubed root of y plus 3 over 4. And we solve it to try and make y the subject. So times both sides by 4. That would be 4x equals the cubed root of y plus 3. Take away 3. 4x take 3 equals the cubed root of y. And then the last step would be to cube it. So we're cubing both sides. So there's two terms, so we put it in brackets. 4x take 3 cubed equals y. And instead of just saying, and the last part is we just switch. So I've made y the subject, and the last bit is instead of y, I'm just going to call it g minus 1 of x. So I switched them at the beginning and I'm now switched them again. So I'm just going to say that equals 4x minus 3 to the power of 3. And the next part is just composite functions. Now, when I'm dealing with composite functions, what I do is I start from like x and I work my way outwards. So first of all, what I need to do is find f of x. Oh, sorry, that should have said an answer. So let's start again. So I'm being asked to solve g of f of x equals 2. So with composite functions, what you do is you always start from the x and you work your way outwards. So you find the f of x first and then you substitute that into g. So I know that I'm putting f of x, which is this, into g of x. So wherever I see an x, I'm going to put this whole expression here. So g of f of x is going to be the cubed root of 2x plus 3 plus 3 over 4. Okay, so that is an expression for g of f of x, and I know that g of f of x equals 2. So I know that the cubed root of 2x plus 3 divided by 4 equals 2. So all I need to do now is solve it like an equation. So I times both sides by 4. So the cubed root of 2x plus 3 equals 8. I can then take 3 from both sides. So the cubed root of 2x plus 3 equals 5. The next thing I'm going to need to do is cube it. So x cubed. So 2x plus 3 is going to be 5 cubed, which is 125. Then I subtract 3. So 2x equals 122. And the last step, if 2x equals 122, I'm just going to divide by 2. And x is going to be equal to 61. Okay, so please don't let functions scare you. This type is just substituting. This type, you just make, you switch the x and the y variables, and then you solve to rearrange the subject. And for the last type, start with this and then put it inside the next one. Okay, and if you have to solve something, just make that expression equal to what you're trying to solve. Okay, so for the last question, we're dealing with the turning point of a curve, and it's not as scary as it seems. All it literally means is where the curve turns, okay? And the way we do that is generally you've got a quadratic And the only way to solve it, well, to find the turning point, is by completing the square. So completing the square, you always end up with x plus a and then minus b or something. Like, that's just how you do completing the square. Now, your coordinates of your turning point are always going to be whatever this is, the inverse of it, and then whatever this is, that's the coordinate. So this will make a little bit more sense when we go through this, but that is all we need to know for turning points. So we've been given this equation here. Now, whenever you've been given a quadratic, you always want to rearrange it. So in this case, I'm finding the turning point of a curve, so I want to get it in the form y equals. So that would be y equals minus 2x squared plus 16x plus 7. Now, I'm going to need to find, this question doesn't tell you, but normally they do. They say by completing the square, find the coordinates. So I'm completing the square, but this is a little bit of a difficult one because I've got a negative coefficient of x. So what I'm going to do is I'm just going to deal with this part, okay? Ignore the plus 7 for now. I'm going to leave it to the side. We'll come back to it later. And what I want to do is just factorize this negative 2 out. So if I factorize the negative 2 out, that would be x squared, but here I need to get a positive 16. So negative 2, if I just halve that, negative 2 times by 8 gives me negative 16. So this is going to be negative 8x. Okay, so that's a little tricky sticking point. So I factorize that and I'm left with plus 7. So what I want to do is just complete the square of this expression here. Completing the square just means finding the square. If you need me to go over that in more detail, just let me know. But for the purpose of this question, I'm going to assume you know how to complete the square. So when we're completing the square, we halve the coefficient of x. So that would be x minus 4 squared. And if you need to do working out, just do it to the side. X minus 4 squared, what would that actually give me? Well, that gives me x squared minus 8x plus 16. And the expression that I need is x squared minus 8x. So therefore, to get it back to 0, I take 16. Okay, so this expression here, I've completed the square, and I've still got that negative 2 lurking on the outside, and I've got this plus 7 lurking on the outside. So next, what do? Well, I expand everything back out. So that would be minus 2, x minus 4 squared, and minus 2 times by minus 16 is positive 32, and I've got 7 on the side. So I simplify that even further, minus 2 x minus 4 squared plus 39. And remember what I said about the turning point? It's going to be the inverse of whatever is in here for the x coordinate. So the inverse of negative 4 is 4. And then whatever this is going to be the y coordinate. So that is how I'd do that question. And we've come to the end of the paper. So if you do need any help on any topics, any clarification, there are probably videos that I've done in the past that I can link to you. So just leave a comment, or if there's something I've never covered, then I can maybe quickly make another video. But good luck for tomorrow. I'm sure you'll be absolutely fine.